Whoa, Tasha, you are. Why are you awake? Oh my goodness. Great, great, great. Zoe, what grade would you like me to do? Why don't we just pull a spin like this? Let's say the person who can have say as to what needs to be done. I think now I need to pull a number on people here because I found that you guys. No. Don't tell me about so late. You should be asleep. You should sleep. You can go to bed. You should be the one. You go to sleep and tell me about you should go to sleep. And nonsense is this you're giving me here in the live. All right, do you have and tell me stuff? All right. Shh. There's people here. Don't play with me here. Don't play. Zian. People are always ready to come on here and tell me what to do. Please do analytical geometry. Zian, what grade are you in? Let's start there. What grade is Zian in? Zian, grade 11, please. Grade 11, please. Is Jan even aware of the fact that you're asking me to do analytical geometry, but it's a topic that has passed and gone as far as the term you are going into is concerned? So you are going into term, what is it? You're going into term 3, right? Did you do analytical geometry in term 2? Because in term 3, my guy, you're not going to have analytical geometry happening. That's just one thing you need to know for sure. Okay. Zian is KZN is not done with the exam. So does that mean that you're gonna be doing? Oh, Zian, you are part of the crew that has been pulled a number. So that's why you are saying please do analytical geometry. No wonder. Okay. No, it's fine. Let me attend to you then, Zian. Since you want analytical geometry, let's attend to you. I think it would only be fair. And in actual fact, I don't mind it. I don't mind. Okay, I don't mind. I think, guys, from next time onwards, if you guys want to have special requests for me to do a particular thing, then I will suggest the following, that you guys, you must gift. You see, if you gift, then you can request. Today, I'll be generous. I'm going to be generous today. I'm going to do analytical geometry for grade 11s. But I'm going to do it because it's coming from the goodness of my heart. That's it. Next time, if I come onto the live and you want me to do a particular topic, the gifts must come forward. Right? Let me just make it clear and be honest. Me, guys, there's one thing, that's why I kind of miss, who's this? There's a particular lady that always joins, Mrs. Him. I miss Mrs. Him. Mrs. Him, when she comes onto the live, she always gives. It's encouraging, guys. If you are a person who is doing what I'm doing and you are doing lives out of the goodness of your heart, I think some of you've seen that, okay, this guy is just doing these lessons, it's nice. So you have no problem with just watching me do the lives, and after that, thank you so much. It's and that's it. But like, there's no I don't know, like some of you, you have the capacity. Some of you have parents, for crying out loud. Some of you can actually have data for days. You can, you can spend ice cream with this girlfriend who is not even going to stay with you forever, or boyfriend, call it what you want. But you cannot gift someone who is helping you with your academics on the live. So that's the bone of contention I have to pick with you. Whereas you have someone here who is purely, like I said, a person my love language, I call it my love language. My love language is gifts, guys. It's gifts. I know some of you have the love language of touch. I know some of you have the love language of words of affirmation. If I tell you long enough what an amazing person you are, the good things that you do, even though you feel like you are the most trashiest person in the world, you feel motivated and encouraged. So we have different, inclinations, if you want. Call it what you want. Yeah, thank you, Sam Kelly, by the way. All right. But like I said, I would hope that things like this happen not because I'm asking you to, but because hopefully when there's this thing that's happening with you and you feel like, hey, this guy is really helping me a lot, then something would come from you that, hey, let's do like this, Yeah, let it not be something that you are doing because I have coerced you to do it. Yeah, well, please let it be not that. Okay, so let's do this. You said analytical geometry. Okay, so let's start it from the level that I think will be most applicable to us. Okay, you are the one that asked for it. This is analytical. Question 3. The coordinates of triangle A, B, D, there's the triangle A, B, D, are given as -5 and 4. There is -5 and 4. And guys, when you look at this diagram, remember that in analytical geometry, your diagrams are represented on a Cartesian plane. So I hope you know that this is a y-axis, this is our x-axis, right? Your y-axis, all values above x, the y values above x, all of these y values are positive. The y values here. So everything that is y above here should be positive. So you see A, look at the y value. It's positive 4. You see point B, look at y, the y coordinate. It's positive 5. You see? Because everything that is y above the x-axis should be positive. So when you look at the diagram, it should speak to the points in the different quadrants. All right? So x on this side is always positive, but x on this side is negative. Okay? So if you look at the x value here, it is negative. But look at the x value there, it is positive. Look at the x value here, it is negative, rightfully so, because everything that is x on this side is negative. But everything that is x on this side is positive. Everything that is y above here is positive. But everything that is y below here is negative. So look at the y here. It's negative, rightfully so. Look at the x there. It is negative, rightfully so. All right? Are we together here, people? So when you look at the Cartesian plane, you look at the diagram, you look at the coordinates, it should speak to the values of y, the values of x. The values of y as you know them above the x-axis, meaning the y values are positive here, the values of y below, which are negative. The values of x on the left, negative, the values of x on the right, positive. If you've got that down, then guys, that your starting point for analytical geometry is good. Let's move on. Now we can go and read the statement. The coordinates of triangle ABD. Do you guys know what a triangle is? Do we all know what a triangle is in this life? Do we all understand what a triangle is? Hey, I wonder if you know what a triangle is. I wonder. The coordinates of triangle ABD. Okay, right? The coordinates of triangle ABD are given as, look at A. A is -5 and 4. Okay, Greatest Lob says a triangle is a two-dimensional, 2D means two-dimensional polygon with 3 sides. Okay, your spelling is very funky, the Greatest Orb. Okay, Kill WW, I'm glad this life has brought you back to reality, to real life. You must come back to reality because you can't stay in fairyland forever. Okay, the coordinates of triangle ABD are given as A -5 and 4, B 3 and 5, D -1 and -3. Below, E, we are told, is the what? Is the midpoint of BD. Do we know what a midpoint is? Midpoint, the middle of a point, the middle point of a line segment. So E is the midpoint of BD. Where is BD? Here is B, here is D. Where is E? E is here. By looking at where E is, do we already have an idea of what the coordinates would look like? And by that, the X value, what are we expecting the X value to be like? Are we expecting the X value to be positive or negative? What about its Y value? Are we expecting it to be positive or negative? You know, given what I said earlier on, what did we say about X on this side? Hey, what did we say about X on this side? What did we say about Y above here? Hey, guys. These are the things you need to have a comprehension of when you do analytical geometry. I know there's many formulas and stuff, but the basics are this. Please understand how the coordinates ought to look like in different quadrants in your Cartesian plane. I beg you. So for instance, in this quadrant, by quadrant, look at the Cartesian plane is made up of how many quadrants? 4. 1, 2, 3, 4. In the first quadrant, both X and Y are positive. In the second quadrant, X is negative, Y is positive. In the third quadrant, X is negative, Y is negative. In the fourth quadrant, X is positive, Y is negative. Very important, that understanding. Because once you know that, you can expect an answer that is a certain way. And the minute that answer does not come out that way, you know something is wrong with your calculation. You see? So we start right there. So E is called the what? The midpoint of BD. What is a midpoint? It is the point that is midway. It is halfway between B and D. It is a point that is halfway between B and D. This also then suggests that DE is equal to EB. That's what this midpoint thing means to us. But now practically, how then do we apply the knowledge of the midpoint so that we can be able to move in answering the question that's here? Because the first question that we are being asked now, after this information has been laid out for us, is this 3.1. Calculate the length of BD. Leave your answer in said form. Calculate the length of BD. Leave your answer in what? In said form. Where is B? There is B. Where is D? There is D. This here, as Goketo is saying in the comment section, with a big love heart on his face, on her face, is very simple. The length of BD we have the coordinates of B and of D. So if we are to calculate the length of BD for a measly 2 marks, we simply use the what, guys? We use the distance formula. And for our grade 11 learners, the distance formula, right, is found in this beautiful document, which we call the formula information sheet. Grade 12s, I told you that you must be familiar with this document. It's a very important document. It's there in the question paper that you get given. So this here is your formula for distance. And it's simple, guys. It is saying that the distance between 2 points can be calculated simply by the difference of the x coordinates, you square them, plus the difference of the y coordinates, you square them. You put them under the square root, voila, your answer. All right, voila, your answer. So let's do it. We are going to now write BD is equal to. Then let's write the coordinates of B so that we can see what it is we are dealing with. This is B, 3 and 5. D, -1 and -3. You have the responsibility then as a learner to say, okay, this is my first point, this is my second point, depending on what you say. If you say this is your first point, then it means that this is x1, this is y1. Your first point, your x coordinate, your y coordinate for your first point. Then this one will be x2, y2. As the second point, we say this is the second x coordinate, the y coordinate for your second point. Are you with me? Then all you do is you go and substitute into that formula sheet. All you need to do is just go, guys, and write down that formula sheet and you substitute the values. So all you do now, you just copy x2 minus x1, the whole thing squared, plus y2 minus y1, the whole thing squared. You just copy. You are copying now. x2, come, let's grab x2. What's x2? -1. Minus, there's already a minus sign in the formula, don't forget it. What's x1? It's 3. You just write. You're copying now. y2, it's 3. -3. Right? That's -3. You just copy. Negative y1, 5. So it's -3 minus y1. It's 5. Okay? It's 5. You're just copying. All of you are copying. And then you just grab your calculator inside. Right? Inside. Okay? I mean, you don't even have to be doing what I am doing currently. You just take your calculator, you substitute. Your calculator will give you the answer in set form. I am harvesting it. I'm here to harvest the answers. Oh, my soul. So all you do is you have that thing, you see, you have the values, you just take your calculator, you just punch. Yeah, so I am punching there. You can see I'm punching, I'm just punching. I'm grab my calculator, I'm grab, just punch. I'm just punch, I'm just punch, I'm just punch, I'm grab. All doing, grab. Okay, make sure, guys, your calculator is better than mine. You have your things visible. You see my, old it's come out, I have this tendency of giving away calculators. Now I am left with a funky calculator because I give away. Learners, they need more. There we have it. The answer is equal. You can see the answer is 4√5 and 4√5 what? Units. Okay, and that's it. That's BD. Because remember, they said there, calculate the length of BD. Leave your answer in what? Third form. They told us said form. Guys, if you don't know it, this here, the answer with the square root is what we call simplified said form. So if they say leave your answer in said form, you leave it like this. You don't round off. You don't leave decimal places. You just leave like this. Are you with me? So I'm just going to write in brackets. This is what we mean by said form that is simplified. Okay, so 2 marks. Okay, just went to the formula sheet, identified the points. Because it's BD, I write down my coordinates for B, identify x1, y1, my first point, x2, y2, my second point, substitute in the formula. Calculator does the magic. 4.5 units. And remember, had they said to me, leave your answer, round off to 2 decimal places, I was just gonna come here and press SD. Then I would have 8,94 if they had asked me to round off to 2 decimal places. But if they say leave your answer in said form, you stop here, you stop, you are here, because they have been specific. Leave your answer in said form. Don't be sad here and want to leave your answer in a way that they didn't ask. That is very sad. You are going to cry when you find out you lost a mark because you did not follow the given instruction. Are you with me? I hope you are with me. I hope people are with me. 3.2. Let's come here. So what did we learn from this question? We learned that there's a formula called the distance formula. Where is it found? The distance formula is found in the formula sheet. In the formula sheet. Okay? Please. Are you with me? I hope you understand. Now, let's move on. So this is the distance formula. It is used to calculate the distance between 2 points on a Cartesian plane. We can always use the distance formula if we are given the 2 points in the Cartesian plane and we are asked to calculate that distance. Let's look at the second question. The second question says, determine the coordinates of E. Now, they want what? The coordinates of what? Of E. The what? The midpoint of what? Of BD. Where is E? Here is E. Remember what I said before? I said we have an idea what are the kinds of coordinates we should be getting for E. Because E is located in the first quadrant. We are expecting that the x-coordinate of E will be what? Positive or negative? And the y-coordinate of E, we are expecting it to be what? Positive or negative? So we are expecting both to be positive. So there's no ways that after we are done with our calculations, we will get something that is not like that. That's what we are expecting because we know our quadrants and we know our coordinates and the signs of the x and the y in the different coordinates, in the different quadrants. So let us proceed. We want the coordinates of E, the what? The midpoint of BD. Midpoint. What is the midpoint? Chini, again, look. The distance formula, the midpoint formula. Bana. So the midpoint formula is here as well. The only thing that I'm going to do is that instead of writing M here, I'm going to write my letter that they asked, which is they are saying the coordinates of E. So I'm going to write in the place of M, I'm going to write what? E. Let us go. E brackets. Then I'm going to say x1 plus x2 over 2. That is how I get my x coordinate. It is the sum of the x coordinates divided by 2. Then y1 plus y2 over 2. It is the sum of the y coordinates divided by 2. So where are we located here? We are going to be looking at B again and D. Because E is the midpoint of B and D. So we already had identified that this is our first point. So we're going to say x1 plus x2. In other words, we are going to say 3 plus minus 1 over what? Over 2. And this means and y1 plus y2, meaning 5 plus negative 3. 5 plus negative 3 over what? Over 2. Then we solve. 3 plus minus 1, positive times the negative, we have 3 minus 1 over 2, which is simply 2 over 2, which is simply 1. 3 minus 1 is equal to 2. What's 2 divided by 2? That is 1. Then let's move on to this side. 5 plus minus 3, positive times the negative, that gives us a negative. So we have 5 minus 3 over 2. What's 5 minus 3? It is 2. What's 2 divided by 2? It is also 1. So what are our coordinates of E? 1 and 1. That wasn't too shabby, was it? Not at all. So when we want the midpoint of a particular point, we need to ensure that we know what the end points of that midpoint is. And we simply do what? We add the x coordinates, divide them by 2 to get the x coordinate of the midpoint. We add the y coordinates and divide by 2 to get the y coordinate of the midpoint. What were we expecting with the x and the y coordinate of E in this quadrant? We're expecting that both the x and the y coordinate would be positive. Did we get that? Oh, indeed. Oh, indeed. The x coordinates are both positive. That is so reassuring for someone who is busy preparing to write for the exams. Okay, so do you see, guys, that two formulas that we use in analytical geometry? Distance formula, midpoint formula. Let us move on. 3.3. Show that AE, this symbol, what does this symbol mean? AE, AE, what does this symbol mean? Now Spinacha, what's happening? Spinara is saying, say your bracket. What about the bracket? What about it? Spinacha is you say your bracket. Oh, my bracket here. Oh, shame. Spinara, you are a star. Okay, yes. So the bracket at the end. Thank you, Spinara. Right? Thank you. Okay, so in the comment section, people have indicated that this means perpendicular. Very good. So we are told to show that EAE is perpendicular to BD. Where is AE? Here is A. The E would come from A all the way to E. All right, so in our heads, we are envisioning that. We are asked now to show that AE is perpendicular to what? To BD. Now, there is an important thing that we need to understand when we are speaking about perpendicular lines. In analytical geometry, when we say lines are perpendicular, it is because of this one singular condition. We are looking at the gradient of the lines. What about the gradient of the lines? We are saying that the gradient of AE, if we are saying the gradient of AE and the gradient of BD multiplied together give us -1, then it would imply that AE is perpendicular to BD. So perpendicular lines have a product of their gradients being equal to -1. So what we need to prove here, we need to prove that the gradient of AE times the gradient of BD is equal to -1. This is something we are required to prove. The minute we can prove that this here is true, then it leads us to the conclusion that AE is perpendicular to BD. So I'm writing this down so that you can understand the framework that we need to have in mind as we try to prove that AE is perpendicular to BD. We need to find the gradient of AE first and foremost. So let's go ahead and do that. So as part of our answer, the calculation, this is where we start. We find first the gradient of what? Of AE. Let's go. The gradient of AE. Now some of you are going to be like, what? How do I calculate the gradient? And then I come to you and I say, the beloved formula sheet. Look at the formula sheet. This was the distance formula. This was the midpoint formula. Now here I have the gradient formula. The gradient formula simply says the change of y, the difference between the y coordinates in a certain order, divided by the difference of the x coordinate in that certain order should give us the gradient. The change of y over the change of x. Okay, I hope that makes sense, guys. The change of y over the change of x. SPC, I am very random, sporadic, and unpredictable when it comes to going live. Lately, because of time availability, I'm going live in the wee hours of the morning. It's 2 a.m. People are sleeping, but me, I'm cross-nighting. With who? With the people that want to cross-night, because I know exams are up and coming. We have less than 50-something days, guys, before trial exams are written for grade 12s. So, for instance, this, what I'm doing right now, is grade 11 work, but do you know what? It's very relevant to your grade 12s. Furthermore, the grade 11s in KZN have not written, so they are very much wanting to know these things that I'm doing right now. So I cannot say SPC, I cannot say, you know. So those are that's the formula. So the gradient of AE, all right. So A, the coordinates of A are -5 and -4. The coordinates of E are 1 and 1. I've found the coordinates of E, remember, okay? The coordinates of A are -5 and 4. The coordinates of E, I just got them when I found the midpoint of BD. Now, obviously, the coordinates of E are 1 and 1. Therefore, the gradient of AE can be found. Okay, so let's just name and say this is x1, y1, our first point, x2, y2, our second point. Then the formula says y2 minus y1. y2 minus y1 over x2 minus x1. The order is so important. If you start with the 2's, you start with the 2's, please. All right, please, very important. And you end with the 1's. Okay, so y2, that's 1 minus 4. Please, the formula already has a negative. The y1 is also negative. A negative times a negative, you know how it goes. You know how it goes. x2 minus x1. That's x2, it's 1 minus x1. It's -5. You know how it goes. You know how it goes. Negative times a negative, that's 1 plus 4, 1 plus 5. What's 1 plus 4? Is 5. 1 plus 5 is 6. Gradient of AE is 6. Okay, guys, please take note. This is a small letter m, all right, not capital letter, all right, and then subscript AE in brackets to indicate this is the gradient of AE. That's why it's written in this way. So gradient of AE I've found. Now I need to find the gradient of what? Of BD. Let's find the gradient of BD, guys. Gradient of BD. Okay, same thing. y2 minus y1 over x2 minus x1. y2 negative 3 minus y1 positive 5. x2 negative 1 minus x1 positive 3. Negative 3 minus 5 is negative 8. Negative 1 minus 3 is negative 4. What's a negative divided by negative, guys? It's a positive. What's 8 divided by 4? It's 2. So it's positive 2. Okay. Right. Are we okay so far? Alright. So we found the gradient of AE, right? I just want you to double check with me that my gradient is fine of AE, that indeed it is what we say or profess that it is, so that we don't go wrong or go south or go anything. 1 plus 4 indeed is 5, and then 1 plus 5, it is indeed 6. And we did substitute the right coordinates when we did so, did we? y2 minus y1, it was 1 minus minus 4. x2 minus x1 was 1 minus minus 5. So this is fine, this is fine. Then we want to check when we multiply the gradient of AE and the gradient of BD, do we get negative 1? So we say 5 over 6 times 2. And then we check. What's 5 over 6 times 2? It is equal to 5 over 3. Does this give us negative 1? No, it doesn't. Therefore, the gradient of AE times the gradient of BD is not equal to 1, to negative 1. Therefore, AE is not perpendicular to what? To BD. Okay. I hope you guys are good and you understand what we do when we check perpendicular line. Okay. Someone in the comment section is saying, but it says prove that it is perpendicular. Okay. All right. So is there maybe an error that we made? We can double check, right? Because it's important to double check. Okay. Remember, at the end of the day, guys, we are led by the calculation. If the calculation leads us to a place where we can see that the product of the gradients does not give us negative 1, then we can't conclude and say it is when it's not. Okay. All right, so let's just check again if our calculations were done correctly, so that if it is that I made an error, we can fix that very quickly and we can actually get on to winning ways. So let's see, maybe there's something that I did that is incorrect. And what is that? So the coordinates of A, I wrote them incorrectly. That's what went wrong. Okay, so Michaela there, thank you very much. You know, Michaela is very much awake and alert. So when I wrote down the coordinates of A, right, look at the coordinates of A, it's negative 5 and 4. But what did I write down? Negative 5 and negative 4. Okay, so when I make mistakes in the live, I celebrate that. Okay, personally, I do. Okay, I don't beat myself up at all, but I celebrate it, because it becomes an important moment for me to reflect on what I did, but also for you as the learner to actually realize that you could find yourself in the same situation if you are not paying attention to every detail of the work that you are doing. Okay, so I celebrate that moment because it is a learning curve for me and for you. So it's very important for us to not do that. Okay, no, that's fine. If stumbling in this trauma if stumbling on this life gives you trauma, that's fine, I guess. Then it means you need to redefine what failure is for you, because if you are becoming traumatized by failure or by missing the mark, and you are not allowing that to be something that teaches you something, then you need to redefine what stumbling and making a mistake means to you. Because the reality of life is that mistakes will plague your life. And when they do, you are the one that chooses as to whether you're going to learn from them and make them to become stepping stones or stumbling blocks for your life. So it's all about perspective and how you view things. So guys, let me then just go and fix then. Okay. Let's just fix then this -5 and what? And -4. It was not supposed to be -5 and -4. It's supposed to be -5 and +4. All right. So thank you so much, Michaela. Michaela is so vigilant and so much aware. I'm sure a phenomenal student there in the making, no doubt. Okay. So what we have there is a -5 and what? And 4. So that means when we substituted y1, we are supposed to substitute what? +4. That obviously then makes this become 1 minus 4. And then obviously the 1 minus 4 gives us what? 1 minus 4 gives us -3/6. So this was supposed to be -3/6, which is -1/2. So the gradient of AE is -1/2. So this was incorrect. Very much so, -1/2. Now we can see the sense in them asking us to prove that the gradients should, with their product together, give us -1 to prove perpendicularity. So the gradient of AE is what? It's -1/2. And then what's the gradient of BD? It is 2. So when we multiply the 2, what do we get? A -1. Okay, makes sense? All right, so I hope now we have our hopes restored. Confidence has come back. Okay, so now that we see that the product of the gradients is equal to -1, then we can conclude, therefore, AE is perpendicular to what? To BD. And that is supported by the fact that the gradient of AE is the product of the gradient of AE with BD is actually giving us -1. Okay, I'm satisfied. Thank you, Michaela. Michaela, you're a star, that's for sure. You are a star in the making, and I'm hoping that personally, if you are in grade 11 or grade 12, I don't know what grade you are in, that the maths marks, they are reflecting, this identification of the error that I had made here, and it's actually reflecting even in your performance at school, which is great. Okay, are we happy, guys? Are we satisfied? So whenever we want to prove that lines are perpendicular, we need to find the respective gradients of the lines. Gradient of AE, gradient of BD. Then after that, we take those gradients. Guys, we just take those gradients as they are, multiply them, and check. Do you get -1? Okay? Because the theory is that perpendicular, or let me say, the product of the gradients is equal to -1 for perpendicular lines. Okay, the product of the gradients is equal to -1 for perpendicular lines. So that is the concept behind what we did here, to prove that lines are perpendicular, it becomes important for us to calculate the gradient of the one line segment, which is AE, then calculate the gradient of the other line segment, BD, and then after that, take these two respective gradients, multiply them, and check what you get. If you get -1, then it proves that the two lines are perpendicular. You conclude by such. And obviously that is why you've concluded as such, because you found indeed that the product of the gradients is equal to -1. It is proven. Okay. All right, let's move on to the next question. The next question says, determine the equation of the line parallel to BD and passing through A. I repeat, determine the equation of the line parallel to BD and passing through A. Okay. So what they are saying, in other words, is that in this sketch, there is a line that is parallel to this line, BD. It's parallel, so I can, in my head, in my mind's eye, I am envisioning another line that's here, okay? And it's parallel to this one. It's passing through the point A, because that's what it's saying. The line, equation of the line, it's parallel to BD and passing through A. Okay, and Cheese Boy in the comment section is enlightening us very nicely that if they are parallel, what does it mean? It means that the lines have the same gradient. Okay, so in other words, read the statement again. Determine the equation of the line. This line is parallel to which line? BD. Do we know what the gradient of BD is? Were we able to calculate the gradient of BD in any of the calculations before? All right, I think we did here. We did calculate the gradient of BD and we found what the gradient of BD is. So that means this new line that is parallel to BD, we already know its gradient. Okay, and you guys are saying it very nicely in the comment section, that it was the gradient of BD. Katie is saying gradient of BD is 2. Spinara is also saying the same thing. So that means then we need to then determine the equation of the line. So what do we know we need in order to find the equation of a line? We need two things to find the equation of a line. We need 1, the gradient, 2, a point that lies on that line. So in order to find the equation of a line, we need two things. We need a gradient and we need a point that lies on this particular line we are talking about. Now it seems very apparent that the gradient we are going to be able to have very easily. You guys have already helped us in being able to spot what the gradient will be. So we all agree that the gradient of BD is equal to the gradient of this new line. Okay, I'm just going to say it's called the new line, which means the gradient of that line is 2. Why? Because of parallel lines. Okay, parallel lines have equal gradients. Okay, parallel lines have equal gradients. So this is very interesting, that parallel lines, we know if this is line 1, this is line 2, we know that the gradient of line 1 would be equal to the gradient of line 2. Whereas perpendicular lines, if this is line 1 and this is line 2, then we know that the gradient of line 1 times the gradient of line 2 should give us -1. This is very important. So for parallel lines, gradients are equal. But for perpendicular lines, the product of the gradients equals minus 1. And that's just for the purpose of those that just need to know. Okay, yeah. I just thought I should just throw that in there. So the gradient sorted. We need a point. Do we have a point that lies on this new line? Do we have it? What is the point? What is the point that lies on this line? According to the statement of the question, it says determine the equation of line parallel to BD and passing through who? Passing through A. So this line is passing through who? A. So what is the point that lies on this line? It is A. We have the point. What is the point? It is A. So we have the two things that we need in order to find the equation of this line. We have its gradient, and we also have a point. The point is A. And the point A is -5 and what? And 4. Are we together, guys? Hey, are we together? I hope we are flowing together. Okay, no one left behind. No one left behind. So the gradient is 2, the point is -5 and 4. Do you know what's beautiful now in grade 11 and 12? Formula sheet. This formula sheet. This formula sheet is beautiful. Formula sheet, where are you? Here you are. Here, guys. Okay, this is the formula to find the equation of a line. Okay, hi, very nice. Y minus y1 is equal to m into x minus x1. Now I know that in earlier grades, like in grade 9 and in grade 10, you guys used y is equal to mx plus c. You know, you would substitute the gradient, then you'd substitute the point, you'd calculate the value of c, and then you would substitute back the value of c and write the equation. I don't mind. I mean, you could use that and get the answer because you have the gradient, it's 2, and you have a point that's -5 and 4. Not a problem. Not a problem, but also works. But now, we have Mabena. You know, we have Mabena. All right. So therefore we say y minus y1 is simply the y coordinate of the point, which is 4. M we already know is 2, it's the gradient. X minus x1, we know x1 is the point that the function passes through, which is negative side, so it's x minus -5. Then we solve. What's x minus -5? It's x plus 5. We distribute the 2x plus 10. We take the 4 over plus 4. Okay. And then we get the value of the equation. Y is equal to 2x plus 14. Okay. Yeah, so obviously that is one way of doing it. Some people obviously still love this one, y is equal to mx plus c. Obviously this one, that's where you substitute first the gradient, then you take the point, you substitute 4 is equal to 2 into -5 plus c. You get the value of c. Okay. -10 plus c, you transpose the -10, then you get c is equal to 14. When you write the equation, you come back here, you substitute the value of c, y is equal to 2x plus 14. Both methods 100% fine. Both methods 100% fine. Okay, but like I said, grade 11 learners get engraved in their heads this one when they are in grade 11. And then of course, I mean, my grade 10s would probably use this to basically find the equation. But I know some people, even if you teach them this one, they are very comfortable with finding the equation of a straight line using this one. Please, guys, take note that with any straight line that you need to find, you need two things. You need the gradient and you need the point that lies on that line. Once you have these two things, the equation is just simply that. You just use one of two of these methods and you should be fine. Okay. Okay, let's go on. The last question here. Calculate the area of triangle ABD. Calculate the what? The area of what? Triangle what? ABD. Where is this triangle? Here is this triangle. Triangle ABD. Okay. So when they say to you calculate the area, as a grade 11 learner that is exposed to analytical geometry in term 2, you haven't done the area rule, all right, as of yet. You only know one formula to calculate the area of a triangle, and that is area is equal to half base times the perpendicular height. That's what you know, okay? That's what you know. And of course, for this triangle in that Cartesian plane that you have, you had just proven, for instance, that AE is a line that is perpendicular. You proved that. You proved that. You proved that AE is a line that is perpendicular. It's perpendicular to this base, the base DB that's in the diagram. Okay, remember, do you remember that? You proved that AE is perpendicular to BD. You proved that. That's what you did. Okay, so that means for this triangle, you have your perpendicular height. All right, your perpendicular height is the length AE. Okay, and from your calculations that you've done so far, you did not calculate the length of AE, but you are going to need it to calculate the area. So you are going to need the length of AE. That is your perpendicular height. So I'm going to rewrite the formula of area and say area is equal to half. Now, what is the base? The base is always the side that is at the foot of the perpendicular height. So our base here is the side BD, all right? Because the perpendicular height, at the foot of the perpendicular height, we have what we call the base. So the base is BD. So I'm going to say half times BD times AE. So BD is my base, AE is my perpendicular height. So all I need is AE. BD I already have. I calculated BD, it was 405. So I need the length of AE. So let's go and use the what? The distance formula and calculate the length of AE so that we can substitute that back in here into the formula and calculate the area of triangle ABD. Are you feeling me, guys? Like, am I losing you? Are we together? To calculate the area of a triangle, the formula is half the base of the triangle times its perpendicular height. What is the base? The base is the side that is found at the foot of the perpendicular height. We will all bow at the feet of Jesus one day. So what I'm saying is that at the foot